this video, we're going to go through the retaining wall analysis and design module. To begin any of our TEDS calculations, simply click on the New button and navigate to the module you would like to run. Once you've located the module, you can easily just double-click on it or select the Calculate button in the lower right-hand corner to begin the calculation. Don't forget to check out the notes we've included for each module outlining the scope, which codes were used to create the calculation, and any assumptions and limitations that have been made or are present. Once you start the module, your output page will start in the background, and then you will be presented with a series of interfaces. Each one of these works like a book, top to bottom and left to right. You will also notice a parametric sketch on the left-hand side that will continue to update as you move through the interfaces. Due to the size and complexity of this calculation, we recommend that you turn the results off in this window until you have entered in most of the information required to complete the calculation. This will help speed up the processing time. Otherwise, it will need to recalculate every time you enter in a new piece of information. So starting with geometry, enter in a retained height of your soil, the angle of the backfill, if any, the cover distance over the toe, and how much you would like to ignore due to excavation. We will assume this is going to be a basement wall with 7 feet of retained height, 1.5 feet of cover, and we'll assume 6 inches is lost in excavation. Notice that you can simply type in any unit into the input field and it will be converted to the specific unit being required. This can be very handy if you need to switch back and forth between metric and imperial. Next, we will enter in the information for the stem. Notice that you can select a simple cantilever, an inclined front face, an inclined rear face, an inclined front and rear face, a stepped front face, or a stepped rear face. For this example, we will stick with a simple cantilever. On to the base dimensions. Note that the toe length and the heel length is from the face and rear of the stem, making the total base length equal to the toe length plus the heel length plus the stem width. You can choose to add a key by selecting this box and entering in the dimensions and location of the key. However, since this is a basement wall, we will likely not need a key and therefore we'll leave this option off. You can also add water in the backfill by selecting this box and entering in the water table height. For this example, we will assume the water table is 2 feet above the base. And lastly, you can restrain the stem anywhere along the stem, restrain the base from sliding, or both. Since this is a basement wall, we will assume there is a slab in place to retain it from sliding at the base and a floor above to prop the top part of the wall. You will notice that our sketch is updated with all of the information we just input. You can pan around and zoom in and out of the sketch using the scroll wheel on your mouse. Next, we will input our soil details. You can select the top box to include seismic calculations, which will use the Mononobe-Okobe method to develop your loads. For this example, we will leave this off. Next, you will select how you'd like your lateral pressures to be calculated, using either the Rankine, Coulomb, prescribed, or user-defined methods. If you have a geotechnical report, you will likely just select the prescribed method or the user-defined option here in this menu. This window may seem a bit overwhelming, but it is set up to help you if you don't have a soils report. You can enter in some basic information about the soil and appropriate ranges of values will be given to you to choose from. However, you can simply select user-defined for your soil data and this will reduce the amount of input significantly to something you are likely more familiar with seeing. Now you can just enter in your densities, prescribed active and passive pressures, and your coefficients of friction for both the retained and base soils. For this example, we will just leave the defaults. Don't forget to adjust your soil bearing pressure if needed. Next, we will go to loading. In this window, you can add additional loads acting behind the wall or vertically or horizontally on the wall. We will assume there is no additional surcharge on the wall, but we will add a vertical uniform distributed load along the top of the wall to account for the floor framing into it and the wall above. Now you can choose which code you prefer to have the wall designed to, as well as enter in some basic analysis options like the densities of the stem, base, and water, which pressure coefficient you would like applied to the retained soil, and how you would like your bearing pressure distribution. Now we will turn on the stability results. Note that you can select this box to do only the analysis. Because we have restrained this wall against sliding, the only check required is the overturning, and we have satisfied the 1.5 minimum safety factor, so we will move on to design. By hitting the next button, we will move into the design portion of the wall. Like in the analysis window, we recommend turning off the results to speed up the processing time. Here you can choose between a concrete or masonry stem wall and then enter in the associated material properties. We will just accept most of the defaults, but we'll change the front face cover to be 2 inches to match the rear face. In your design options, you can select which concrete code you would like to use, ACI 31802, 05, 08, or 11. You can also select design positions for the stem to segment your wall and allow for different reinforcement layouts throughout. This helps break up tall walls and allows the user to have heavier reinforcement on the bottom or wherever it's needed, but then lighten it up as you move up the wall. Now I'm going to go ahead and turn on the results to see if I need to tweak any of my reinforcement. If a set or reinforcing is failing for any reason, it would show up in red in the sketch beside it. However, you can see that all of my reinforcing is passing as it's all in black text. You can toggle between the different reinforcing design sections using this menu here. Lastly, you need to select your output options. Here you have the ability to change the title of your calculation to something more meaningful for your project. You also have the option to select a full output or a summary of this calculation. Depending on your region and who ultimately will be reviewing these calculations, this may vary. However, it is very simple to switch back and forth as needed. You can also select whether you would like to include the sketches within your output. Once you select Finish, you will get a line-by-line output going through each of the calculations included in the design. Every variable will be defined, each equation written out, and every code reference provided. This eliminates the black box entirely. In this calculation, you will even get a sketch outlining all of the reinforcement along with the cover distances. Now, if something needs to be changed within the calculation, simply click on the Calculate button and the same series of interfaces will appear. Make whatever changes are necessary to update your calculation and hit Finish. The output will automatically be updated. Be sure to check out the other TEDS trial videos that go through each of the other included calculations, as well as how to customize them using TEDS for Word.